9.5, infinite series. So here's my theorem. Let a is of n greater than 0. The alternative series, the sum from 0 to 1, -1 to the n times an, or -1 to the n plus 1 an, converges when the two conditions are met. So we have two conditions. The limit as n approaches infinity of a of n equals 0, and a of n plus 1 is less than or equal to a of n. That means, for example, the next term needs to be smaller than the previous. And we'll have examples. Again, straight from sign. So straight from sign, we have here number 1. Again, we are totally ignoring the -1 to the n, okay? I'm totally ignoring totally ignoring it. So, what do we have? And they're telling you the limit as n approaches infinity of 1 over n plus 4. So you don't even have to write it down. They're giving it to you, okay? So in this case, if you only have n in the denominator, you have a fraction and you have n in the denominator. In this case, as this number goes to really infinity, like in the calculator, you put 1 over 100, 1 over 1,000, it's going to tend to get closer and closer to 0. So in this case, it's going to be a convergence. Okay, so this one's easy. But what happens if it's not that easy? Okay, so it's still easy, but what happens like in this case? Okay. Again, this is my alternating card. Again, you don't have to guess what the limit of. They're giving it to you. In this case, if you have n over 4n plus 8, I'm going to ignore the plus 8 because again, plus 8 is like as you're going to infinity, plus 8 doesn't really matter. The coefficient in front of the n on the top is 1. So when you have n and n in the denominator and they have the same exponent, this is a 1 and this is a 1, we do the ratio of the numbers in the front, okay? So in this case, the limit be, that's where they get the 1/4, okay? That's where they get the 1/4. This is not 0. Remember, it had to be 0. So in this case, my function diverges. It has to be 0. So again, look at this next one. They're telling me the limit as 1 over 5 to the n. Okay, even though here n is the exponent, this is going to grow a lot faster. Okay, this is going to go really, really quickly. It's going to be large very, very quickly. Remember, let me go back to number 1. Remember they said that the next one is smaller. So I want to know what is of 1 and what happens for n's of 2. When we plug in 1, I have 1 over 5, 1 plus 4 is 5. And this one, if I plug in 2, I have 1 over 6. I have 1 over 5 and 1 over 6. To know which one is bigger, we can do a cross multiplication, cross this 11 this way. So we'll have 6 and 5. The 6 is greater. That means that this is my first, this is my second. The second is smaller. Okay? 1/5 is greater than 1. So again, just to verify that first, that second condition, okay? So again, on this one, going back to number 3, this goes to infinity, goes really, really quickly. It's big, really, really quickly. So what happens for 1, for n equals 1, and for n equals 2? So it's going to be 5 to the first power would be 5. 5 to the second power would be 25. We're comparing 1/5 to 1 over 25. The 1/5 is greater, so the second term is smaller. In this case, again, if I put infinity in my denominator, as you can see here, it's going to get really quickly really small, very, very small, almost touching 0, okay? So in this case, it's going to be a convergence, and that's it.